Alright, I'm going to talk to you about dilations. And dilations are a type of transformation. And unlike translations, rotations, and reflections, which are also transformations, those three transformations only change the location of the object. They do not change the size, they do not change the shape. So when you're translating, rotating, or reflecting, those type of transformations, those shapes are congruent. Same shape, same size, they're congruent. Well, with dilations, when you are transforming the object, you're transforming the size of the object. You're making it larger or you're making it smaller. The idea, though, is that it's proportionally larger or smaller. And so every side is multiplied or divided by the same factor. So that's why it stays proportional. But because it's a different size, same shape, the shapes are then similar. So the dilated object or figure is similar to the original figure. So let me do a couple of examples. So first I'm going to plot these 4 points, and then I'm going to dilate them using a scale factor of 2. So let me go ahead. I've got point A, which is at 1, 1. I've got point B, which is at 1, 2, 3, 1. I've got C, which is at 1, 4. And then I've got D, which is at 3, 4. And so I'm going to connect my dots. Notice my points are labeled. Alright, so there is, I've graphed rectangle ABCD. Now I'm going to dilate it using a scale factor of 2. So that means I'm going to multiply each coordinate, each x value and y value in here by 2. So that means that A prime is now going to be 2, 2. B prime is going to be 6, 2. And again, I'm sorry for my handwriting on these. C prime is at 2, 8. And D prime, really looks like a D, does it, is at 6, 8. So now I'm going to graph these points. 2, 2, there's A prime, and you want to make sure you identify that point as being the prime. 6, 2. C prime is at 2, 8. And then D prime is at 6, 8, which is right here. And then again, you want to connect the lines, or connect the dots, form lines, so you can see the shape. And you can see here, the red rectangle is our original rectangle ABCD, and the blue triangle, or the blue rectangle, I'm sorry, is the dilated rectangle using a scale factor of 2. So every side is twice as large. So here, where it's 2 units, now it's 4 units. This side was 3 units tall, now it's 6 units tall. So every side is proportionally larger than the other side. Okay? I'm going to stay consistent with that. Now, this one is dilating, making it larger because it's a scale factor of 2. If it's a scale factor of 1, the object does not change size. It's going to be the exact same size, because if you multiply every x and y value by 1, you end up with the exact same x and y values. So a scale factor of 1 does not change the size. A scale factor less than 1 decreases the size. So here's an example using a scale factor of 1/2. This is triangle ABC, so I'm going to go ahead and plot these points. First one, A, is at 8, 8, so 1, 2, 3, 4. Alright, so here is A. B is at 2, 6. And C is at 6, 4. Excuse me. And then let me connect the dots here to show our triangle. Alright, now we're going to to figure out what our new coordinates are going to be. And so we're using a scale factor of 1/2. And so whenever you're figuring out your new coordinates, you multiply by the scale factor. You multiply your x and y values by the scale factor. So multiplying 8 by 1/2 is the same thing as dividing by 2. So 8 comma 8 is going to become 4 comma 4. B prime, oops, I labeled it prime. B prime is going to be at 1 comma 3. And C prime is at 3 comma 2. And so now I'm going to plot these points. I didn't mean to put that one there. And there is our dilated triangle ABC using a scale factor of 1/2. Notice it's smaller. So it's every side is 1/2 the size of what it originally was. So this side's half of what this was. This side is half of what this is, and this side, I'm sorry, this side is half of what this side